That was dumb.
Hi everyone, we're the BC RoboCats, and today we will be giving a short overview of what Roadrunner is and how we use it. So, Roadrunner requires utilizing Android Studio and having it fully installed with the FTC FDK and the Rev hardware client. And we also recommend having a basic understanding of Java. That way you are not throwing yourself into a very complicated programming application.
You also need to utilize motor encoders or odometry pods so you can track your robot's movement on the field and overall just make it more accurate, autonomous.
So Roadrunner is an open source motion planning library that allows for accurate positioning of your robot, and it uses utilizes the positioning that you get from either the dead wheels or the encoders to gain the positioning and the heading and accurately move on the X and Y grid that it gives.
So Roadrunner uses all the math from your encoders and dead wheels to control the exact position of the robot on the field, as well as the heading of it. It's contained in custom commands that use the information gained from these encoders and dead wheels to move it relative to where it is currently on the field.
So Android Studio is arguably the best programming application you can use. It has the most versatility and it has the most tools you are able to install, Roadrunner being one of them. Another example would be April tags. It's also able to tell you some things you're doing wrong, like basic Java code. You're not able to tell what's wrong if you're using ABA Java or blocks. There is negatives to using Android Studio instead. There's a higher difficulty curve, and there is difficulty maintaining it and keeping its code up to date.
So odometry pods versus the built-in encoders with your motors. The encoders are a standalone thing. They're not attached to your motors, so there's no difficulty with that. They're very accurate and use the dead wheel rotations to track your X and Y coordinates on the field as well as your yaw. The built-in encoders use the pre-existing motors, so you don't have to buy a new component. They're very simplistic to use, but they are less accurate and they're prone to wheel slip.
So the pros and cons of built-in encoders are the fact that the pros are that it's already built into your input motors, so it's a lot cheaper and it's a lot more cost efficient. But there's a lot of cons with the fact that it's a lot less efficient when it comes to overall movement, and it's not as accurate as dead wheels would be compared to it. Also, over time, the slippage of the mechanism wheels will start to gradually build up and make it much worse than it used to start out as.
The benefits and downsides of the odometry pods. They're high precision, so they're much more accurate. They're not prone to wheel slip, as I said. They're not attached to your current motors, so they're their own thing. They track the X and Y axis as well as the yaw, and overall they make your autonomous much more performant and accurate. The cons are there's mechanical complexity. They're individual components, so they make your robot have much more complex assembly. There's an increased cost as they're not integrated in your pre-existing motors, so you have to buy a new component. They require much more accurate calibration and tuning to work effectively. And there's more programming complexity as it has its own programming.
Are there any questions so far?
I think something that might help is if we can get a feel for what people in the room are currently using for programming, and what kind of components they're using on the robots, if they're using motors that already have encoders.
Yeah, so does anyone in here currently have dead wheels? Okay. You did?
No.
Okay.
Maybe.
So you guys are all probably using like either Gobelda motors, Rev motors, and they have the black cap on the end. Yeah, so those are going to be the built-in encoders, and those can also benefit from Roadrunner. It's just the difference between the dead wheels and the built-in encoders is, like they were saying, the odometry pods and the dead wheels are just more accurate because it like they were saying, it separates like the slippage that you would get from the mechanism wheels. It takes that out of your tracking and your localization, so it becomes not part of the equation when you're in autonomous. So you're able to have a much more accurate like movement on the field. Like you're trying to move to where you need to score. 9 times out of 10, the dead wheels are going to be more accurate in getting you to the right spot you want to be in.
So I do have one question. Which do you suggest for a new team
For a new team?
that's not really done a lot of coding or anything else?
I personally would say wait for Roadrunner and not start off immediately. Like, are you saying like
Brand new
just
team.
Brand new? Yeah. Don't start with Roadrunner your first year. It's not worth it.
Okay.
I would just recommend using your encoders.
Once they learn more of Java though, more of the programming language, then I would say start transitioning to Roadrunners and odometry pods, as it will make your robot a lot more accurate. So Roadrunner is utilized by some movement commands in your Java project. It has its own kind of syntax. The basic ones are forward, which obviously goes forward, backwards. You can strafe left, and you can also strafe right. There are also more complex ones that use coordinates on the field to move to. For example, you can spline, which is kind of like this, kind of like a wave. And there's like line 2, which will go in a line towards the coordinates that you set. And yeah, we'll go over those now.
So this is the most basic command you can use. It's just a forward command that's based on hinges. You can often combine it with other commands like a spline or a line 2. And what that will do is it will go forward while making a spline at the same time. And we'll showcase the spline later.
So there's the line 2 command, which I was talking about. So essentially what it does is it takes a vector 2D, which is an x and y coordinate on the field, and it will go in a straight line towards that coordinate.
While keeping on constant heading.
Yes.
So a line to linear heading is, while it is moving, it is moving in a line, and while it is moving, it is gradually turning the robot's heading to meet the target heading. This can also be combined with the forward command in similar ways, because you can do a forward, and then while it's moving forward, you can.
Yeah, so like the real benefit of a movement like that is, since you're using mechanism wheels, if you can like drive forward and turn during that same movement. So the robot is moving forward and turning. So if you're able to combine that into one like set of movement for the robot, that's going to save you time during autonomous, and saving time in autonomous means you're going to score more points. You have more time to complete the tasks that are set before you. Because like if you were to not do that, you'd have to drive forward, and then that would be its own command, and then you'd have to turn the robot, and that would be its own command as well.
So we have the spline 2 command, which is sort of a curve. It uses a vector 2D, which is the x and y coordinates, and then after that, it uses a target heading, which in our case is 0, so it's just going to face forward. But if you wanted that to be 90, it would be going sideways the entire time.
So these are the basic strafe commands that we also use quite often. Also combine well with splines and lines. Yeah. Yep. So, something we wanted to showcase was how we use a software called MeetMe. So in those GIFs we showcase, these GIFs right here, those are MeetMe. And what that allows you to do is instead of manually testing your robot on the field every single time and reset it over and over, you're able to set it up on a module and repeatedly test the same lines of code with minor adjustments very quickly and very efficiently.
What is that called? Meet?
Yes, MeetMe.
Yeah.
Like Roadrunner Meet?
Yes, yes.
Mhm.
That's open source, free.
Mm-hmm.
It is one of the, there's a lot of
Sweet.
install tools like that that allow for testing like that. We recommend MeetMe. MeetMe is the most efficient out of all of them. Roadrunner GUI is a little outdated.
Yeah, so really, like, a lot of the reason that Roadrunner is very useful for teams is because it's an open source project that was made by other teams, and lots of teams have contributed to this project and worked on it to make it better. So it's like, it's really the most advanced motion library you could use for your robot, and it's highly polished, and there's just a lot of effort that's already gone into it, and that's just a resource that's available to all teams. So just getting in to like the FTC Discord, like for like the national level of teams, getting to talk with teams across the world, being able to talk with them, and like they will point you to resources like Roadrunner. And getting into that level of communication with other teams, there's lots of different resources just like this that are very useful for teams.
So right here, we've got the start pose. And the start position is your heading that you will start with. It puts you on the map with the X and the Y and the heading, which is the direction of your robot. If you don't have this, your robot doesn't know where you are. It's going to assume you're at 0, 0, which obviously isn't where you're starting. So you have your first command that uses the movement, which is drive trajectory sequence, and it uses the start pose, and then you're able to put virtually any movement command there. So this is a simple forward command.
That has to start the cradle.
And you need to be connected to the internet. Okay.
There we go. Anyway, that's a simple forward command. And now I can take that same command and make it fade.
So now it's longer.
And then you're also able to do stuff like
So you can combine the commands to give it an overall path to follow. That's shown here. What I also like about it is it gives you a little time frame right here, so you can see exactly how long your autonomous is running.
all right. Are there any questions?
Sweet.
What does the pricing look like for the dead wheels that you mentioned?
So So the go build the dead wheels are I think about $800 or not $800, $180 for 3.
It's about $230 to get a set of 3, but you don't need all 3. You can use only 2, but if you want to have like a very accurate heading of your robot, you would need to use 3.
If you only have 2, you would only have one in the middle and one on the side. When you have 3, you have one on both sides. And we found it to be a lot less efficient to have 2 instead of 3.
Yeah, so if you have 2, you would be using the IMU on the rev controller for your heading. But when you have 2 in parallel, you're able to use, you know, the tracking from those for your heading of the robot.
And do the wheels actually, because you said dead wheels, so I'm assuming they don't actually contribute to like the actual movement, they just more for the tracking aspect of it?
Yeah, they
Right.
just they give back information.
Okay.
Here, you should.
So they're basically just like sensors. Correct?
Yeah.
Yep, they're just free spinning sensors that track the robot's movement. And the reason it's so important to have that is like, say this robot is on the floor right now, it's kind of easy for it to slip around because of the mechanism wheels, they're on the rollers. So, you know, when your robot comes to a stop, it's gonna like slip forward a little bit and you're gonna lose your localization, or the robot's gonna lose a little bit of the accuracy of knowing where it's at. Having the dead wheels kind of eliminates that from being a problem.
Can we see it in action or?
Yeah.
Yes, we can.
Is it the presentation auto?
Yeah.
This way? Okay. Which way is it gonna go? This way?
There's a small
Yeah.
chance it may crash into y'all.
I think it's so notice how it's moving in place kind of, then you readjust. It's on a tile floor, so it's not gonna be super accurate compared to field, but
Yeah, so that was all Roadrunner.
Yeah,
and
so,
that movement it was having, while it was moving to one direction, was it trying to readjust to the proper heading and the proper X and Y coordinates. Yes.
So now with grippier wheels that aren't these, if you're not using mechanism wheels or even the new grippy mechanism wheels that don't have as much slippage, is Roadrunner still worth it? Would it not be better just to use the already built-in motor sensors to act as your encoders if you don't have mechanism wheels?
I would say that mechanism wheels are what makes Roadrunner so effective, and not having mechanism wheels while using it is a big downside, because you can't do a lot of motions. You can't really do lines, you can't do splines. It's basically just having more accurate forward and turn and streaming, or no, not streaming, but more accurate movement outside of the complex stuff that mechanism can do.
So if it's not worth it to have Roadrunner specifically, is there another thing that uses those dead wheels for those simple just lateral wheels, or is just kind of hard coding it the best option you have for those?
yeah, so Roadrunner doesn't actually support anything but having mechanism wheels. So if you're gonna use dead wheels but you're not using mechanism wheels, probably what would be best would be to program a custom controller that utilizes the data from the dead wheels instead of trying to use Roadrunner.
Yeah.
Wait, so Roadrunner is only for mechanism wheels?
Yes.
Okay.
Yeah, so like the principles of Roadrunner could be applied to like a different drivetrain setup, but
It won't be as effective.
right, so like the whole idea behind Roadrunner is that, you know, you can like draw a spline or you can define a spline and the robot's able to move in that spline. So like a spline would be like a vector graphic. So like you could have like, you could, for example, you could draw a 9 and the robot would follow the 9 because it has mechanism wheels. And it will also like keep the same heading. So like the robot won't turn at all, but it will be able to use the mechanism wheels to make that movement and keep itself from turning at all. Do you guys have anything else? Are there any other questions? Like, it doesn't have to be specific to Roadrunner, like we could answer any other programming questions as well.
You guys went to nationals last year, right?
The year before.
Really?
Yeah, so last year, we were the first pick for the winning alliance,
Right.
but, it's just the way that the advancement order worked.
Okay.
We ended up being the first to not go.
Who did go?
It was, cybernetics, lightsabers, and Project Peacock.
Oh, must have been from the other division. Got it. Cool.
But yeah, so Roadrunner is like more of a higher level goal, but we wanted to show it off because we feel like it's one of the things that really is a game changer for us. So that's what I would like to emphasize is if you guys want to like set a goal to like get to for programming, like getting to Roadrunner and being able to understand like the motion planning libraries and stuff like that, that's gonna be, you know, killer in your autonomous, and it's really one of the best things you can work towards.
Usually one of the best ways to optimize your auto. Yeah, so this is learnrotor.com. Goes over basically everything you need to know. There's also a GitHub that goes over the installation process. Actually, we have right here 2 QR codes. This left one is if you would like to fill out a Google form and apply for us to help you tuning and setting up Roadrunner for your team, or just Android Studio, basically just anything programming related with that. And then the right one is for all the codes that we use. So there's a video on how to install Android Studio and Roadrunner. There's yeah, just everything around that.
Oh yeah, thank you.
Yeah, so we definitely did mean to print these out. Unfortunately, it did not make it to the printer.
Yep, took pictures of the QR codes.
That doesn't help me fix.
Yeah, it does.
And get the back.
Patrick, it's 9:30.
That's why I'm trying to wait.
I'm not stalling.
Alright, that's the end of class. Thank you all for coming.
No, one more thing.
They're both in this class.
They're both in this class.
Yes.
And you're from Marcus, right?
So